friends, in this video we will study the classification of errors in the measurement. So let us start with our topic. Through measurement we find the value of an unknown quantity and we use a measuring instrument for finding that value. Now, when we are measuring the value of an unknown quantity using the measuring instrument, the value which we are getting is called the measured value. Now, this measured value is different from the actual value of the unknown quantity. And the difference between the measured value and true value is called the errors in the measurement. Now, whenever we are doing any type of measurement, the result of that measurement is always affected by errors. So, it is very important to study that what are the ways in which the errors can be introduced in the measurement. Because if we know the reason due to which the error is occurring, we can use or we can apply some remedies to eliminate that error. So in this video, we are studying the classification of the errors, that what are the ways in which the errors can be classified, or what are the ways due to which the error can occur in the instruments. Okay. So if we see the classification, the errors are broadly classified into three categories. First is the gross errors. Second is systematic errors. And third is random errors. So these are the three broadly classified ways of the errors. These are the three categories in which the errors can be classified. Now, systematic errors, they are further classified into instrumental errors, environmental errors, and observational errors. Okay, so these are the three classes of the systematic errors. The systematic errors and the random errors, they are collectively called the measurement errors in the case of the measurements which we are doing. So let us study these types of errors in detail. Starting with the gross errors. Gross errors are caused due to human mistakes. When the observer is reading the instrument, then at the time of reading the instrument or taking readings from the instrument, at that time, if the observer has mistakenly written some different reading or he has not correctly taken the reading, so the error which is occurring due to human mistakes, that will be called the gross errors. And in this case, we can see the cases like So these human mistakes, they can occur due to if the observer it is reading the instrument value before the instrument has reached to its steady state. So whenever we are measuring any quantity, first we will have to wait that when the instrument it comes to its steady state, then only we are taking the reading from the instrument. If the pointer in the instrument it is still moving, and before it has come to the steady state, if the observer has taken the reading, so the error which is occurring due to it, that will be the gross error. Also, if like suppose he is taking the reading and he has taken some other reading, and when it is recording that, or when it is noting it on the paper, he has mistakenly written some other number. So if there is any mistake in the recording of the data, then also error can occur. Another type is that when after taking all the readings, when we have to do some calculations, and after those calculations we have to get the value of the measuring quantity. So in those calculations, if any mistake is done by the observer, then also error can occur. Suppose like if we are measuring the resistance by dividing the values of the voltmeter and the ammeter, so in the division of those values, if we have done some wrong division or some wrong calculation has been done, so we will get the incorrect values of the resistance. So due to that, error has occurred, because we will get a different value from which is different from that actual value of the resistance. So that will be a type of gross errors. So all the errors which are occurring due to human mistakes, due to the mistake of the observer, they will come under the category of gross errors. Now, if we talk about an example of gross error, we can have the parallax error. Parallax error is also a type of gross error. Parallax error means like when the observer is taking a reading from a glass tube. Okay, here we want to take the readings from this glass tube. Here we have a liquid in this. Liquid is filled. Okay. Now when the observer, he is reading from these glass tube, he can also read the actual level is this. Okay, we have lower meniscus also and upper meniscus also. So there are different level. When the glass tube is at the same level of the eye, then a different reading will occur. If the observer is reading from some other angle, he will read the upper meniscus, and if he is reading from a lower level, then he is going to read the lower meniscus, that is lower level of the liquid. So different readings will come. Suppose here he is reading as 50, here he will read it as 50.1, and here he is going to read it as 49.9. So different angles of the observer, they can produce different results of the measurement. So that type of error is called the parallax error, and this error is occurring due to the mistake of the human. That is why it is a type of gross errors. Another example of gross error is like suppose the person or the operator, he is measuring the pressure from the pressure gauge, and the reading is 1.01 Newton per meter square. Okay, he has read that it is the pressure in the gauge. Now when he is reporting that pressure, at the time of reporting, he has mistakenly reported at 1.10 Newton per meter square. So actual reading was 1.01, but the operator, he writes at the time of the recording on the paper, he writes 1.10. So mistakenly, due to the mistake of the operator, the reading has been written as different. So this is also an example of gross error. So there are various ways in which the operator or the human, it can create an error in the measurement. So how we can eliminate the gross error? Careful reading. When the operator or the person is reporting or reading the instrument, then at the time of that reading, if he is careful at the time of reading and recording the data, then the gross errors, they can be reduced to some extent. Now, second type of classification of error is the systematic error. When we are doing any type of measurement, we use the measuring instrument for doing the measurement. Now, if there is any mistake in that measuring instrument, the reading will be wrong. Okay, and due to the wrong reading, there will be an error. So, systematic errors are those errors which occur due to the fault in the measuring instrument. Suppose, like if the measuring instrument is not calibrated, if the pointer of the measuring instrument is not accurate, then error can occur. A well-known example of systematic error is the zero error. Zero error occurs in those instruments which are of indicating type. Indicating type means we have a pointer there, and due to the deflection of the pointer, we can measure the unknown quantity. Now this pointer, it moves over a scale, and this scale has various divisions on it, like from 0 to the, like suppose if it is measuring from 0 to 100 amperes of current. So the ammeter, it will have the readings from 0 to 100. Okay, and the pointer, when the ammeter is not connected in the circuit, then the pointer should be at zero position. But when it is not at that zero position, it is like just tilted towards the positive side or towards the negative side, then an error can occur when we are using that ammeter. Because like suppose if the ammeter pointer is there, it is at like 0.1 amperes position. So when we are measuring the current of like suppose 1 ampere, so instead of 1 ampere, it will give us a reading of 1.1 amperes. So error has occurred because actual value was 1 ampere, but we are reading it as 1.1 amperes. So due to the pointer of the ammeter, this error has occurred in the measurement. So this type of error, this pointer has to be at 0, but it is towards the positive side 0.1. So that type of error is called positive zero error. If the pointer is at like below the zero, so due to that error which is occurring is called the negative zero error. So zero error, it is can be of positive zero error or a negative zero error. Okay. Now these systematic errors, they can be eliminated by doing the calibration of the instrument. Calibration means that we are using a standard quantity whose value we already know. Okay, and then we are measuring that standard quantity from the instrument, and then we are calibrating or changing the readings of the instrument so that the instrument reading is equal to the value of the standard quantity. Suppose like here, if we are measuring, we know that the current flowing through the circuit, through a particular circuit is 1 ampere. Okay, so we are going to connect this ammeter in that circuit. Okay, and we will make it sure that the instrument, it will come back towards the at the 1 ampere position. Okay, when it is at 1 ampere, we will change its pointer, we can type the screw on the ammeter so that the pointer will be exactly at the 1 ampere, and then we can, it means that we have done the calibration of the instrument, and then we can use that ammeter in to measure the current of other circuits also. So now, systematic errors, because it is occurring due to the fault in the measuring device, so it can be of three types. One is the instrumental error, second is the environmental errors, and third is the observational errors. So, starting with the instrumental error. Instrumental errors are those errors which occur due to the wrong construction of the measuring instruments. At the time of constructing the measuring instrument, if any error or any default has occurred, due to that default, the measuring instrument will not be able to measure or will not be able to measure the correct quantity. Okay, so due to construction of the due to the default in the construction of the measuring instrument, if any error is occurring, that will be the instrumental error. Now, these errors, they can occur due to hysteresis or due to friction. When the device, if the instrument is having very heavy parts in it, and when the parts are moving and they are touching each other, so the moving parts of the instrument, they can have friction in between. So due to the friction, the wear and tear losses can occur in the instrument, and due to which the performance of the instrument decreases. And due to the decrease in performance, the error will not give us the accurate results, and error can occur. So it can occur due to hysteresis. Now, instrumental errors, they consist of like they include loading effect. Hysteresis means that when we are applying an input, when we are increasing the input to the instrument, we are also getting the output which is increasing. Now, when we are decreasing the input from the full scale reading to the zero scale, then also we can get the same output. So these instrumental errors, they include loading effect also and the misuse of instrument. Loading effect means like when suppose we are increasing the input from 0 to the full scale reading when we are taking, then the output of the instrument is also increasing. Okay, like if this is the input, we are changing the input from 0 to the full scale of the instrument. Now, as the input is increasing, the output is also increasing, you can see. Now, when we are decreasing the input from its full scale, this is the full scale of the instrument. Now, when we are decreasing it from full scale to the 0, then also the instrument, it should follow the same curve, but it is not following the same curve. It goes in some different way. So this is called the loading, and this is called the unloading, and this phenomena is called the hysteresis. Now, this hysteresis, it can occur in the case of electrical instruments also, and in the case of magnetic instruments also, because if there is any change in the electric and magnetic field, then at the time of input, at the time of increasing the level, and means in the upper scale and in the lower scale, so at in those time, if the conditions of the instrument are different, then we will get the different result. Loading effect is also, that means when we are connecting two or three stages together, then the if the in stages, these stages are not compatible with each other, then loading effect will occur. Also, due to misuse of the instruments, like when we are carrying the instrument from one place to another place, during that transportation of the instrument, if some damage has occurred to any part of that instrument or if its internal circuitry has been disturbed, so due to that the errors will occur in the measurement. So these errors which occur due to the wrong construction or due to the mistakes in the instrument, those are called the instrumental errors. Okay. Next type of systematic errors are the environmental errors. Now, as the name suggests, the environmental errors, they occur due to the environment. Like if any if any changes are taking place in the external environment of the instrument, so due to that, if there is any effect in the reading, then an error can occur. External environment means like if the surrounding temperature of the instrument is changing, then also it can have some effect on the readings, like humidity, pressure, or the temperature they are changing, or if there is any stray magnetic or electric field which is surrounding the instrument, due to that also there will be an effect on the readings of the instrument. So if any error is occurring due to the changes in the external environment, then that will come under the category of environmental errors. So environmental errors, they occur due to some external conditions of the environment. If the external conditions are changing, then they will affect the readings of the instrument. Now these external conditions, they may include the pressure, temperature, humidity, or due to the presence of the stray magnetic and the electric fields. Now how these environmental errors, they can be reduced? We can reduce the environmental errors, like if there is any change in pressure, so we will try to maintain the temperature surrounding the instrument as constant, so that no changes can occur due to temperature. Humidity should also be maintained, so we will try to maintain all the external conditions as constant around the instrument. Also, we can ensure that there is no electric and magnetic field present around the instrument. So we can, the first measure is to maintain the humidity and temperature as constant. And second way to reduce is to avoid for electric and magnetic field, we can provide a shield around the instrument, so that these magnetic fields and electric field, they cannot affect the instrument. So if any error is occurring due to the environment surrounding the instrument, then those will call other they will come under the category of environmental errors. Next type of errors are observational errors. Observational errors occur due to the wrong observations or readings which are taken from the instrument by the observer. When the observer is taking the readings, at the time of that recording of the reading, if he has done any mistake at the time of observation, that will cause an error. So observational errors occur due to the wrong observations or reading in the instruments, and these errors they particularly occur due to the observer, okay, who is taking or recording the readings. Now a common example of observational error is the parallax. Now, this parallax error occur because of the different levels at which the observer is taking the readings. Suppose that again taking the example of like vernier calipers. Now, in vernier calipers, we take the readings. Now, in vernier calipers, there are two screws which are rotated with each other, and we have to find the point where the two screws their readings coincide with each other. Now, when we are making the reading, if the observer has done some mistake to record that reading, due to that, parallax error can occur, because due to the difference in the reading at the time of reading, if any mistake has been done, so due to that error can occur. Now like if we are reading from a glass tube, so at if we are at the if the glass tube is at the same level of the eye, then we will take a different reading. If the glass tube is at a lower level than our eye level, then we will read the upper meniscus of the liquid, and if the glass tube is at an upper level than our eye level, then we are going to read the lower meniscus. So in all these three cases, the readings will be different. So this type of error is the parallax error, and it comes under the category of observational errors. So these, if we want to remove the observational errors, we have to be careful at the time of taking the readings from the instrument. So these are the three types of the systematic errors, that is the instrumental, environmental, and the observational errors. Next type of error is the random errors. Random errors, they are caused by the sudden change in the experimental conditions, like when we are taking the readings from the instrument. At that time, the temperature was different, pressure was different, the humidity around the instrument was different. So due to some environment changes, if any, due to the experimental conditions, like and when we are taking the readings, the temperature should be maintained at 50 degrees Celsius. Now suddenly the temperature has changed, okay, and also like if we have placed the instrument on a flat top, and suddenly the some vibrations has occurred, due to which the instrument setup has been changed. So due to that, if there is any change in the experimental conditions, or some noise has occurred around the surroundings or in the surroundings of the instrument, or the working persons who are working with that instrument, they are tired, and due to their tiredness, when they are taking the readings, they are not so much accurate at that time. So all the errors which are occurring due to these reasons, they come under the random errors. So examples of these changes are like if there is any change in the humidity or pressure, or there is an unexpected change in the temperature, and if the power supply is connected to the instrument and if there is any fluctuation in the voltage, so due to that also an error can occur. So if there is any sudden change in the experimental condition and due to that if the errors are occurring, then these are called the random errors. Now these errors, they can be reduced by taking the average of all the readings which are taken, because we cannot make any changes in these experimental conditions. Okay, these experimental condition has changed. Now we have taken all the readings, so we are going to take the average of all the readings so that an average value of the measured quantity can be taken. So these are the random errors. So in this video, we studied the classification of the errors in the measurement systems, and we studied that the errors are classified into three broad ways. One is the gross error, second is the systematic error, and third type is the random errors. Systematic errors, they were further classified into instrumental, environmental, and observational errors. So all these types of errors we have studied in detail in this video. So I hope that this topic is clear to you. Thank you.